Lesson 1-13. Today, we're going to take a look at what we call regressions. If you look at your learning objective, what we're focusing on today is we're going to look at data and come up with what we call an appropriate function type. Not only that, we'll construct a model. Model being a key word that the calculator is going to call a regression. I'd encourage you to write that down because that's the button we're going to be clicking here in a moment with technology. I have my Desmos already open. I would encourage you to open yours up because we're going to be using it all class. So go to your Google Classroom and open up Desmos because we will be using this all class, like I said. Okay, with that, I'm going to get started. By the way, the second learning objective is basically the same as the first. We're using technology to model a function for a situation. Okay, so today, we're dealing with, like I told you, regressions. It's a major component of AP Pre-Calc curriculum. You can read this on your own. I'm not going to waste my time here reading this, something you can do on your own, but I'm going to use Desmos. You can also do this with Inspire. You can check other videos online for that, but I'm going to use Desmos today. So first, let's look at example 1 here. It says the age in weeks and the weight in kilograms of 5 randomly selected babies from a particular pediatrician's office are listed in the table below. There's the data. Secondly, or part A here, says the weight of the baby 2 weeks after birth can be modeled by this function W given by all of this. My first question for you, what is in the place of X? Because I don't have an X in this problem. T. Okay, very important for you that once you notice that, I would go to your table and put an X because it's going to matter for Desmos in a moment. Just put, that's X. I'll just do an arrow, which means that this is X. What is W of T? Y. Okay. And yes, if you're going to ask, by rule, X data comes first, Y goes second. So go over to your Desmos. Mine, I know, looks different than yours. If you're at full screen, I know it's going to look slightly different, but it's the only way I can fit everything on. Hit the plus and choose table, or you can just type in table if you prefer. Type in table and get yourself a table up. Let's type in our values. So my X values, or T values, you could say, are 4, 5, 6, 8, and 12. Type those in, and then type in your Y data. If you're watching at home, just pause the video until you get those typed in. Okay, one of the things that's not required to do, but I'm going to do all day because it is helpful for us long term, is to see this as a correct scatter plot. Hit the zoom fit button. It looks like a magnifying glass, the plus. This problem tells us it's a linear equation. It actually doesn't use the word linear, so I should just ask you, that does show us a linear, but it doesn't say it's linear. When you look at this, what shape does it appear closest to resemble? A line. So what I want you to do now is up by where your variables are, you'll see these dots with the line through them. What this is going to do is it's going to generate an equation to go through the dots. Go ahead and click that button there. Now when you do that on Desmos, the automatic regression is linear. That's the automatic. If you had a different type, you would choose something different there, but we're saying it's linear. This right here is going to be our equation. Let's go ahead and copy that over. I'm just going to copy and paste it. You go ahead and write your equation down in your packet. That is the equation that we're going to be using in a second. Oh, I'm not even following my instructions. Sorry. Let me follow my instructions. Part AI says write 2 equations that could be used to find the values for constants m and b and the expression for w of t. Okay, so here's what this means. We want to make sure that without a calculator, you know what the process would be. Now, this type of question, you're always allowed a calculator. So here's what the process would be. If you were writing, you would take this equation right there, and you would plug in 2 data points. Now, why it says 2 is because right there it says 2. 2 equations. We would choose 2 data points, and we could choose any 2 we prefer to solve for m and b. So looking up here, you could choose any 2 equations you want, or any 2 data points. So you could choose like this data point. I'll call this data point 1. How about just P1 for point 1? If I plug this in, 5 would go in for what value? Look over here. What's 5? T. And what's 4.4? WT. So WT comes out. WT is 4.4. We don't know what M is, but we know T is 5. Now on the t part, you put that in parentheses, plus b. That's one equation right there. That's 1. Now, my second point, again, you can pick any point up there. Y'all just call out which one you want me to use. The one that starts with an 8, how about that? We'll use this as data point 2. This will be my second equation. You would plug in those points. Again, 5.1 is the WT. We don't know M, but we know T is 8 plus B. Now, if you wanted to use algebra, you could go through this process to solve. But those would be my two equations. That's AI. That would get you a point right there. That's how you would get that point. Now, secondly, it says find the values for M and B. This is, I do not ever use algebra myself. I use the calculator. It's too easy, and it doesn't make mistakes. This is our equation here. What value represents M? I hear 0.185. And remember, you have to have 3 decimals. And what value represents B? 545. I cannot round this one because you need 3 decimals for my class. So this one, the values as given, that would be it. So that's how you would get your points for both AI and this is AI right there. And this would be AII. I know that sounds weird, but that's how you would keep track of what everything is. Okay, does that make sense on how I did that?
Yes.
Pretty simple, right? You just plugged in first time, but I used the calculator to solve. Okay, go to your next slide. You have part B. On part B, it says using this model from part A, BI, what is the predicted weight of a baby that is 10 weeks old? Now, here's the key. Whenever you get the number, circle the number with whatever you want to call it, the units or whatever type it is. This says 10 weeks old. Go back over, 10 weeks old. Is that a T value or a WT value? What is, if it's weeks? And yeah, you can look over here and it tells you as well. T is weeks. Okay, so T represents what in this problem? Sorry, what variable? X. Okay, so what we're going to do in our calculator is we're going to say X equals 10. So now come to your equation. Do not delete anything. Go to a new line and type in X equals 10. Don't type in T equals, type in X equals. Everybody cool with that? All right, you'll notice that it intersects your graph. Go ahead and click where the graph and that new line intersect one another. So it says, what is the predicted weight of a baby that is 10 weeks old? Well, what do y'all think the predicted weight would be? Y'all catching on quick. It's going to be 5.395. The weight, which is a W value, I'm going to write it this way. W of 10, we would guess, is going to equal 5.395. And this is in, what units is this? Kilograms. Kilograms. That would be my weight right there. Questions over that? Okay, I'm going to keep continuing on. In this same line of thinking, part BII says the weight of a 6 baby is 5.3 kilograms. What is the predicted age of this baby? Okay, something has changed. This time on AII, it says the weight is 5.3. What is weight? Go back over here. Weight is our Y. So this time they're telling us the Y is 5.3. Any ideas on how you think you would solve this one? Very good. I'm just going to change this equation here. Y equals 5.3. Again, click on the intersection. Now, in my class, you need how many decimals? 3. You have to have 3 decimals. So we have to have 3 decimals. So the answer would be here. This is in weeks. So you could say T equals if you want, but as long as you say weeks, the weeks would be 9.48. Technically, you can round or truncate. I'm going to be exact on this video here. Would this be a 6 or should it round to a 7? 6. 9.486 weeks. All right. Now, as the slide says at the bottom, don't delete this. We're going to return to it in just a second. Okay. Am I ready? Are y'all good? Move on. All right, good. Now, next thing we're going to look at, it's called residuals. The next thing we're looking at now is residuals. So what a residual is it's basically a measurement of error. I know that sounds weird coming out of my Texas, what do you call it? When you accent. Yeah. I'm not talking about air you breathe here. I'm talking about how much something is correct versus incorrect. It makes sense what I'm talking about here? Error, ERROR. Okay. A residual measures the error. So what is a residual exactly? It's the actual value minus the predicted value. The predicted value here, check this out. The predicted value is like the W value itself, like when you use the calculator. The actual is from the table. Let me do it this way. It's like what you get in the table minus what the calculator thinks it's supposed to be. That's what the residual is. You'll see it labeled this way, where the Y is the true table value, and the Y with what they call a Y hat, is the calculator. So when I look at this here, I have just an example to show you. This over here is what we call a typical scatter plot. Next to it is a residual. A residual, no matter what equation you're looking at, a residual will have a center line like this. This is the prediction. Go ahead on this red line right here, put that this is the predicted amount. This is the prediction. So on a residual, you'll always have a flat line. Always, always, always. It'll be flat like that. That's the prediction. What these dots are is how much the prediction is away from the actual value. So let me be clear. Do you see these purple dots right here? If you counted up how many purple dots there are here, there's always the exact same amount here. What this does is it measures off how much each one is. So this one at the coordinate 70, 21. Here's my line for the prediction here. I'm going to go ahead and put this prediction. Here's my prediction. Now, is 21, or at this point here, 70, 21, is it above or below the prediction? It's below. Now come over here. You see how it's also below? The residual value would be called -5. That's the residual. That right there is your residual. What that means is it's 5 different than the prediction. So if the real value was 21 and it's 5 underneath, what was the predicted amount right here? What would the predicted amount be if I added a predicted amount right here? Let me do it in blue. What would the predicted amount be? Okay. What would the predicted amount be right here on the line? What would be the coordinates of that predicted amount? Does anybody know? 70, 26. How'd you get 70, 26? Well, using the residual, how much was it off? 5, and it was 5 underneath, which means this point's got to be 5 above. What's 5 above 21? 26. Does that make sense? That's how a residual works. Okay, so let me see if I answered that. 2 coordinates are shown in the scatter plot and residual point where the units are in thousands. What is the predicted price of a vehicle with 70,000 miles? So the predicted price would not be $21,000. So these prices are in thousands. That's what the actual value was. The actual value was 21,000. What's the predicted cost or price of a vehicle with 70,000 miles driven? $26,000. That would be your predicted price. That's the predicted price. Let me put that in there. Predicted price. What was the actual price? 21,000, but our predicted is 26,000. So that's how a residual works. Now with that, let me talk about why we use them. When you use residuals, you can tell, number one, if the plot is good or bad, like a regression. You can tell if your regression is good or bad using the residuals. If there's no distinct pattern, it is a good residual. I'll say that again. This seems backwards. If the residual has no distinct pattern, it's a good table. Now look at this one. Do you think this one's good? Do you think this line is good or bad when you look at it? Don't ignore the slide on the left. Just looking at the line. Does the line go through most of the points decently, you think? Yeah. So what we're going to see is we'll see a residual that has no pattern. If your residual has a pattern, what that means is your original was not a very good equation. So what am I trying to say? Let me choose quadratic. That looks decent. Let me choose a different one. Let me get one that doesn't work. Okay, this one's kind of bad, but the worst, no, got excited. Let's just leave it as it is. I'll show you as we go. Okay, so in example 1, we're coming back to it. Remember how I said don't delete this data? Now we're going to do a residual. We want to know what's the residual of a baby that's 5 weeks old. So here's what we do now. Come over to your calculator, and on the side, right under linear regression, you see where it says residuals plot? Go ahead and click that button now. Plot your residuals. Now really concentrate here because you need to catch this. After you hit plot, you'll then need to hit zoom fit on this residuals part because it's going to change the zoom away from this. So residuals, plot. To help us out here, it says, what's the residual of a baby that's 5 weeks old? Now remember, weeks old was which variable? X. This is when X is 5. So if you need help again, you can type in X equals 5. So I'll change this from Y to X equals 5. It's this residual right there. That's the residual we're looking at. If you need help finding it, that's it. It's not letting me click it. There it is. Now it's clicking it. Are y'all getting the same point as me? Okay, that's going to be our residual. So I'm going to copy this over. Okay, so the residual that's 5 weeks old. Here's what that means. This means the actual data point. That right there is the actual. The x-axis represents the prediction. This x-axis, this is the prediction. Is the actual data greater than or less than the prediction? Less than. Yeah, what this is meaning is that the actual weight, let me write it, let me just type it in. What this means, here's the interpretation. The actual weight of a 5-week-old baby is 0.07 kilograms less than the predicted weight. Now I'm going to go get the actual values in a second. Weight of a 5-week-old baby. Okay, just to be clear, look on the original table. What was our actual data for a baby that was 5 weeks old? What was our actual data? 4.4. So the actual weight of a 5-week-old baby, I'm going to put this in parentheses, is 4.4 kilograms. Is 0.07 kilograms less than the predicted weight of a 5-week-old baby. So what would be the predicted weight of a 5-week-old baby? If you're not sure, zoom back out on the real line. I'm going to go back to zoom fit. I'm going to zoom fit this one. And what was the... Sorry, I can't tell which one I'm hitting here. There it is. You see how it's predicting at 4.47? Why am I getting 4.47? What's off here? Am I just doing bad math? 4.47 kilograms. Oh, 0.07. There we go. I didn't realize it was 0.07. I was adding 0.7. Okay. So notice, you see how they're 0.07 apart? This is 4.4. This is 4.47. Y'all realize that? Yeah. So that's what the residual is telling you. So finally, if a baby that is 7.5 weeks old has a residual of negative 0.7 kilograms, what was the actual weight of the baby that was 7.5 weeks old? So to help you out on this, I'm going to give you the formula again. The residual, I'll do capital R for residual, is equal to the actual minus the predicted. Y'all remember that? That was the formula from the previous slide. On this problem, what does it say the residual is? Negative 0.7. If that's the residual, and they don't tell us the actual, that says... Okay, thank you. I'll give it to him. All right. We don't even know any of that. Let's go find out. Let's go find 7.5 weeks. Is that a T? Is that an X or a Y? Okay, this is an X. So I'm going to type X equals 7.5. And what we're going to do here is we'll type in X equals 7.5. We hit residual. I'm going to zoom fit on the residuals here. No, I won't. It's not on there. I'm going to zoom fit on the line. The actual weight. No, this is not actual. This is the predicted. I'm sorry. I keep saying the wrong thing. The predicted weight. Are y'all getting the predicted at the same values as me? Yeah. Okay. That's the predicted weight. So we're going to plug in our numbers and we're going to come up with what the actual weight would be for a 7.5-week-old baby because we don't have that in our table. If the predicted weight, we don't know the actual, that's regular Y, minus the predicted weight of 4.9325. Now we could round that, but I'm just going to leave it like that. How would you solve for Y here? That's right. All you have to do is add 4.9325, and you would have the actual weight of the baby, 4.9325. If you add that like that, now we know what the actual weight is. I'm just going to go type this in right here to make sure I don't make a mistake. Negative 0.7 plus 4.9325. That's going to be our weight right there. The actual weight, and this you could round if you wanted to. The actual weight, which you could write Y if you wanted to. The actual weight would equal 4.2. I'm just going to write all four decimals. 2325 kilograms. So that is using regressions.